How can we learn from data? What can we learn from data? What can we not learn from data? Let's consider this example. All right, so suppose we are out there and we want to know if doing exercise will reduce the blood pressure among senior citizens. That's a useful topic. A lot of people care about that these days. So consider this. Suppose we go out there, we gather our random sample of 300 senior citizens, then we ask them, do you exercise at least 60 minutes per week? We measure their blood pressures, and now suppose we find out that the average blood pressure is a whole lot less among the people who exercise, and it's a whole lot more among the people who don't. All right, remember, we always have to consider our friend the null hypothesis, which says that there's no effect here. Exercise has no effect on blood pressure, so any difference you get is just going to be due to just natural random variation. It's messy here on planet Earth. Every person is different, yada, yada, yada. We do the math, we do the statistics, we find, yay, our difference is significant. Therefore, can we conclude that exercise causes lower blood pressure among senior citizens? No. No, we cannot. So why? How come? I mean, we did our study. We randomly got our people. We asked them to exercise or not. We measured their blood pressures. How could this not work? Well, here's the problem. Usually people who, put in the effort, who are out there trying to be healthy in one way are trying to be healthy in many other ways. So for one thing, okay, healthy people tend to exercise regularly. Also, healthy people tend to eat plenty of fruits and vegetables. Also, healthy people tend to drink plenty of water. Healthy people tend to see their doctor regularly and get medicine for high blood pressure if they need it. And, there's like a million other factors out there that could be out there that we haven't thought of. So maybe it isn't the exercise itself that causes the blood pressure to be low. Maybe the blood pressure is low because of one of these other factors, the fruits and vegetables, seeing the doctor, getting blood pressure medication. We have no way of knowing, based on this study, the way we've done it, the way we've described this, we have no way of knowing one way or another which factor is the actual cause, whether was it the exercise that did it, or whether the fruits and vegetables did it, or maybe the blood pressure medication. We can't tell one way or another. So what we've got here is an association. What we really want is causation. We want to know whether a cause-effect relationship is happening here, whether doing this exercise causes our blood pressure to be lower, whether this thing makes that thing happen. On the other hand, what we have here is just an association, also called a correlation. We don't know. I mean, we know that there's a relationship here. We've established that. We did the math, whatever. We found that. We can establish that these things are related, correlated, associated. We just can't tell whether this thing caused that thing or whether both of these two things are caused by something else. I'm a super healthy person, so I eat the vegetables, I do the exercise, I drink water, I see my doctor regularly. So I can't know which one of these factors or a combination of these factors. I can't tell what's the cause and what's the effect here. So how do we do that? How do we know if this thing causes that to happen? Now, in this case, if exercise causes a low blood pressure. What I need to do is another type of study. I need to do a controlled experiment. In order to be a controlled experiment, I must randomly divide the sample into at least two groups, randomly choosing who goes into this group and who goes into that group. At least, so we need at least two of them. One of the groups needs to be the treatment group. That's where we apply the potential cause factor, the explanatory variable. That's where I say, okay, you people, I want you people to exercise at least 60 minutes a week for the next couple of months. And this, to the control group, I give them different directions. I say, okay, you guys are forbidden from doing exercise. So we withhold the cause factor, the explanatory variable. So those people are not going to exercise. Then, after the experiment, I don't know, a couple of months, then we measure their blood pressures. We measure the response variable, and we see if there is a significant difference now. Because if there are these other factors, and some people eat the vegetables, and some people see the doctors, and all that other stuff out there, well, since we randomly assign people to the two groups, well, there's probably going to be roughly equal numbers of vegetable eaters in both groups. There's going to be roughly numbers of lots of water eaters or healthy people or people who see their doctor in both groups. The two groups are roughly the same. The only difference, we assign them randomness, and let's face it, we own randomness. We know everything there is to know about randomness. We're going to study that later in the course. We know how randomness works. And so the only difference between the two groups is this group was assigned to do the exercise and this was assigned to not do the exercise. That's the only way we can establish a cause-effect relationship, and it allows us to establish a cause-effect relationship. Since that's the only difference, if there is a difference in blood pressure, then we know that that must be the result of the only real difference, which was in this case the exercise. The key thing is, though, we have to do the assigning. We have to choose who goes into this group and that group. We have to tell people whether they're going to do the exercise or not, and we have to assign them back and forth in a purely random sort of way. On the other hand, the more easier type of study to do, the study we described at the very beginning, is what we call an observational study, a survey. And then this is the case where we don't have the direct control over the sample, assigning them to this group or that group, telling them to do this or that. Instead, what do? We call people up, we ask people questions, we measure them in some way. We measure things, whether it's people or tomato plants or lab rats or whatever it is, we're just measuring the results. This is also what happened if I study existing data. I go over people's medical records. I go over people's consumer records, their buying habits, all this sort of thing. I'm not applying some cause factor to some portion of these. Instead, the members of my sample, we're all treating everybody pretty much the same. We're not dividing them into different groups and treating them differently. Instead, no, we're measuring them, we're recording them, we're studying them. This type of study is a whole lot easier, far, far cheaper, simpler to do, and so most studies are done in this way. But a survey observational study cannot demonstrate causation. We can't do that because there are always these confounding variables out there. You can always brainstorm other factors out there which might be the actual causation. So all you can ever get from any survey observational study is an association, a correlation between variables, because there's always these other confounding variables and factors out there. So usually you do this first. You do a bunch of these observational studies and, hey, it looks like this. Then, you write a grant, you get a bunch of money to do the expensive, the difficult, the hard thing, the controlled experiment. Only the controlled experiment can establish causation. So how do we do this? How do we set this up? Well, in order to do this, first of all, remember, we got to randomly assign people to the different groups. I'm flipping a coin. I'm getting a random number out of the computer that's telling the people go to the different groups. You get this, you do that. If I'm doing like a medical study, it's really important that the only difference is this factor. So if I give, I don't know, drugs, I give pills to this group and this group doesn't get the pills. Well, this group knows that they're not getting the pills. So, oh, shoot, I'm in the control group. Nothing's happening to me. Now I'm going to be depressed. Maybe that's going to have an effect on things. So if I want to do this really well, what we do is we give placebo pills. That's just empty pills, sugar pills, whatever, the pills that do nothing to the control group. So nobody knows which group they're in. Because as a result, what happens is there's the thing called the placebo effect. If I give people a treatment and they know they're being treated, usually they're going to report, hey, I'm feeling better, even if the treatment is totally useless. So if I'm giving pills to everybody, then the placebo effect should be the same. The only difference is whether you actually got the treatment or not. And even more than that, usually I'm going to design things so it's double blind in case that not only did the people not know whether I'm in the control group or the treatment group, but the researchers, the people who are actually interacting with them, they do not know who's in, so they can't, like say, oh, this is in the control group. Yeah, well, sorry about that, buddy. No, since they don't even know which group is which, there's no way that anybody can contribute their expectations or their thoughts or what they think's going on there. The only difference is who's getting the treatment and who is not. So as a result, to summarize this, first of all, the explanatory variable, that's the thing which I think is at least a potential cause factor. The response variable, that's the potential effect thing that I think might be going on here. A controlled experiment, that's really important. That's where we randomly divide our sample into multiple groups. We give our explanatory potential cause factor to the treatment group. We withhold it from the control group, and usually there's multiple groups here, and they're giving different levels of the treatment, 60 minutes of exercise to 120 minutes of exercise, that kind of stuff. And then afterwards, we measure the response variable, in this case, the blood pressure, and a controlled experiment is the only way that we can establish a cause-effect relationship. That's what we want, a causation, cause-effect relationship. relationship means this is what we got where one thing causes another thing to happen. On the other hand, if I've got a survey observational study, I'm not controlling, I'm not forcing this upon this group and taking it away from that group. Instead, I'm measuring them. I'm gathering data. It's good data. It's useful data, but I'm not controlling this. So as a result, from a survey observational study, the only thing I can get out of it is an association, a correlation. There's a relationship here, but I don't know whether this thing causes that thing or that thing causes this thing or some other thing causes both of them to happen. And so as a result, whenever I've got a correlation, association, there might be all these other confounding factors out there, other factors which are the real cause, and since I haven't controlled things, I don't know which one is the real cause.